Okay, so the first thing we need to review is central angles. Then in a plane, a circle whose vertex is at the center of the circle, that refers to a central angle. So if you look here, the central angle here would be angle AB, or AOB. It's not going to be right. So let's do that. I'm not going to get temperamental on me. So angle AOB is a central angle. I'm sorry. Okay, it's the central angle of circle. Oh. Okay, an arc is part of your circle. An arc is this right here. This is an arc. It's the part of the circle that your central angle cuts off. So your central angle gives you this. And you're going to label it, it's a minor arc because it's less than 180. And this is how you label it. You put a little arc mark and AB. Arc AB is a minor arc. Then also you can have BC. From B to C. That too is a minor arc, BC. There's a little arc mark above it. Okay, major arcs then are, major arcs measure more than 180. And you would need 3 letters. So you need 3 letters to name a major arc. So we can go A, B, B, arc A, B, B. So now you're going all the way around that circle. And then right here. A semicircle is an arc whose endpoints are the same as those of a diameter. They measure exactly 180. So a semicircle in this would just be A, B, C. Any questions over there? Okay, the measure of a minor arc is equal to the measure of the angle. The measure of the angle equals the measure of the arc. So since angle AOB equals 60 degrees, that means arc AB is also 60 degrees. Because angle DOC equals 120 degrees, that arc BC is also 120 degrees. questions over that? The measure of the major arc is the measure of the major arc equals 360 minus the measure of the related minor arc. So in this, when we had A, B, B, all of this, you can just take 360 and subtract the part that's not included in that arc, minus 60, to get the 300. That is the measure of arc ABB. So basically, to find the measure of the arc, you're going to be adding and subtracting all the angles. Any questions on that? Nope. So in this now, we want to tell you that BB is a diameter of circle A. That will help us find all the measures of these parts. Okay, so we're going to start with the measure of BB. Diana, can you tell me what the measure of CD would be then? 148. It is the same measure that central angle. The central angle is 148, so the arc is 148. Okay, then we want arc CDB. So C, D, C. Anyone have some idea as to how you find that? Yeah? Very good. This is a semicircle here. So you're going to do 180. Plus the 148 to get 328 degrees. Any questions over that? Okay, then we're going to need BCD. So B, C, D. You have an idea? Okay, well, we want the whole thing though. Okay, well that way, we don't need to know this because this is all 180. You just told me that, right? So you just do 180 degrees with the semicircle. But what you just said, that'll give me BC, this right here. So I need to take 180 and then subtract the 148. To get 32 degrees. The measure of BC, arc BC. Any questions over that? Okay, now the next one I'm not going to tell you that there's a diameter there. We cannot say that there's a diameter there unless I add everything up and find that it equals 180. Okay, so don't assume there's any diameters. So we want to start with BB. Very good. Okay, very good. This angle and this angle will give me BB. So 42 plus 83, 125 degrees. I don't know why this is right here, so let's do it. Next one would be BF. find BF, we have to add up all of these sides, or not these sides, these angles. 42 plus 83 plus 53 plus 45. And what's that give me a total of? 223. Then we subtract that from 360. And so what does it measure? 137. Because I don't know for sure that BE is a diameter. And if I added this side all up, it would not be 180. So it's for sure not a diameter. Even though it looks really close to it. And the last one would be BED, which is BED. So I'd have to add the 137, the 45, and the 53. To get what? How's it going? Pretty easy? And down tracking. Okay, the arc addition postulate is what we've been doing, adding the two smaller arcs to get the bigger arc. So in this case, to get arc BD here, we added BC arc BC plus arc CD. No, we're just doing the letters for it. The two parts are going to go that way. Any questions on that? Okay, two congruent circles are congruent circles if they have the same radius, which we kind of already talked about. Two circles are congruent. Right, there's only really one measure on a circle, it's the radius or the diameter. Okay, and if they're equal, then the whole thing's going to be congruent, right? Congruent arcs are a little bit different. Two arcs are congruent arcs if they have the same measure, and the arcs of the same, they're arcs of the same circle or of congruent circles. That means if I had two different circles, like here's a circle, and then here's a circle. If this was 30 degrees, and this is also 30 degrees, are these arcs congruent to each other? They might have the same measure of 30 degrees, but they're not really congruent, they're not the same length. Because one is clearly a bigger circle, so that arc length is going to be bigger. Does that make sense? In order for them to be congruent, okay, this would be, I'd have to have them on the same circle. Let's do this A, B, C. Now, since these are both in the same circle, these arcs should be congruent. Does that make sense? So, arc AB would be congruent arc BC. But this arc is not congruent to these arcs. Any questions? homework, for 10.2, I have 1 through 18, 19, 21, 22, 24 through 30 even, then 33, 34, 92, 37 through 40. All. Any questions over that? Yep. Question. Yeah. I'll be right there.